So the question I was given is silver nitrate in solution reacts with potassium iodide in solution to form the precipitate silver iodide. The first part of the question is to calculate the theoretical yield of silver iodide if 7.82 grams of pure silver nitrate reacts with an excess of potassium iodide. Now the first part to solving this problem is to create a balanced chemical equation. So let's start with silver nitrate. AgNO3 plus potassium iodide reacts to produce silver iodide and potassium nitrate. Now just looking at the chemical equation, we know that it's balanced because there are the same amount of atoms of each type on the reactant side as the product side. So now, looking back at the question, we can see that they gave us a mass for silver nitrate, which is 7.82 grams. So we can write the mass underneath silver nitrate on the chemical equation to show that they are related. So the mass of silver nitrate is 7.82 grams. And now the next step is to calculate the molar mass of silver nitrate. So the molar mass of silver nitrate can be calculated by taking the molar mass of silver, which is 107.9 grams per mole, plus the molar mass of nitrogen, which is 14 grams per mole, and then plus the molar mass of oxygen times 3, which is 3 times 16 grams per mole. And this comes to a total of 169.9 grams per mole. And now with these two pieces of information, we can now calculate the number of moles of silver nitrate. And this can be calculated with the formula N, number of moles, equals mass over molar mass. So we just have to plug in the numbers. N equals 7.82 grams, 7.82 grams over 169.9 grams. And so the grams cancel each other out, and we're left with a total of roughly 0.046027 moles. 0.27 moles. And now looking back at the equation, we can see that silver nitrate and silver iodide have a 1-to-1 ratio. And using this ratio, we can calculate the number of moles of silver nitrate produced. So looking at the ratio is 1-to-1, which means there's the same amount of moles of silver iodide as silver nitrate. So we can write that down underneath silver iodide. It's the exact same. So 0.046027 moles. And now all we have to do is just find the mass of silver iodide. And to do this, we need the molar mass of silver iodide. And this can be calculated by taking the molar mass of silver, which is 107.9 grams per mole, plus the molar mass of iodide, which is 126.9 grams per mole. And this comes to a total of 234.8 grams per mole. And using these two, we can rearrange the formula over here and find the mass. So once we rearrange the formula, it should be M equals N times mm, or mass equals number of moles times the molar mass. So the molar mass of silver, or the mass of silver iodide, is 0.046027 moles multiplied by 234.8 grams per mole. The moles cancel each other out, and now we're left with roughly 10.80714 grams. And this number right here, 10.80714 grams, is the theoretical yield of the first part. Now in the second part of the question, it asks, experimentally, the yield was found to be 9.34 grams of silver iodide. What is the percentage yield? So the percentage yield can be calculated by taking the theoretical yield, by taking the experimental yield and dividing it by the theoretical yield. So percentage yield equals the experimental yield divided by the theoretical yield, and then multiplying it all by 100%. This is what gives us a percentage. So we take the yield, the experimental yield, which is 9.34 grams, so 9.34 grams, and we divide it by the theoretical yield, which we have calculated over here to be 10.80714 grams. 10.80714 grams times 100%. Grams cancel each other out, and we get roughly 86.42%. This would be the percentage yield. Now on to question 3. If the silver nitrate used for this experiment was only 96.2% pure and 7.82 grams of this reagent was used in the experiment, what would be the percentage yield? So we can see that we have already calculated the theoretical yield of 100% pure silver nitrate, of 7.82 grams of 100% pure silver nitrate. So in this question, it is asking what would happen if it was 96.2% pure. So these two questions are the exact same, except the only difference is the percent pure, is how pure the silver nitrate is. So what we can do is we can take this percentage that we received from question 2, the percentage yield, and then multiply it by the decimal form of the percent pure. So let's move over here. We know the, for question 2, the percentage yield, the percentage yield is 86.42%. And we can find what the percentage yield of a 96.2% pure silver nitrate by multiplying. So we're going to multiply this percentage yield by the decimal form of the percent pure. The decimal form of the percent pure would just be taking the percent pure number, the value, and then dividing it by 100. So what that would do, it would move the decimal points 2 spaces to the left. So we would just take 96.2, divide this by 100, and then we would get 0.962. And we take this number and we multiply it by 86.42%. And this gives us a total percentage of roughly 83.14%. And this would be the percent yield of part 3. So if the silver nitrate was only 96.2% pure then the percent yield would be 83.14%. And here is the final written summary for the answers of the question.